In this section, we'll be working on the locking system for both the player and enemies. We've tried to explain as many details and concepts related to this as possible to give you a thorough understanding. We go to the Mathematic Free Machine folder and add the turret from the prefab folder to the scene. By holding the Alt key and clicking, we fully expand the subject and remove the components that are not needed. We also change the name of the subject to enemy_turret. The next thing we want to add is the yellow tank, which is located in the prefabs folder under Cartoon Tank Free. These two objects are going to be considered as enemies in the game. For the subject as well, we go to the prefab and select Unpack completely. We change the title of the subject to Enemy Tank. Since the turret is larger than the tank, it's better to make the subject a bit smaller. So instead of 1, we choose 0.5 for its size. We click the tool handle position button and then we change it from center to pivot. This gives us a better view of the pivot of the objects. For the subject, we want to have rotation around the y-axis. And for the subject, we want the rotation around the x-axis. So, we add the box collider components to this object and resize it to match the object we have. We also add the Photon View component. we add the Photon Transform View classic component to this object as well. Then we check the synchronize rotation option again. We select the enemy turret object and create an empty object named aimpoint. And we set this object as child 0 and place it here. For the position, we set the Y value to 1.25. We select the enemy turret again and create another empty object, naming it detector. This will be used for the locking system. We also add the Photon View component to this object. And similarly, we add the Sphere Collider component. We're going to check this trigger option for the Sphere Collider, and also the radius of this collider will be changed. This will be done through the script that gets attached to this object. We go to the resources folder and add player blue to the scene. I previously created the aimpoint object as the first child of player blue and added it to this object. You should also add this for the other players. For enemy tank, we set the Y value to 0. Then we create an empty object under enemy tank and unparent it so that this object is positioned exactly where enemy is. Next, we move enemy tank under this empty object and raise it a bit. We replace the Y offset with 0.75 to make sure enemy tank is positioned exactly on the ground. we select the subject and create an empty object named aimPoint. Similarly, we add another empty object like player blue and name it RayPoint. We copy the rigid body component from player blue and paste it under the parent enemy tank. Similarly, we copy the box collider component from tank free blue and paste it into enemy tank. We change the game object name to enemy tank and add the Photon View and Photon Transform View classic components. Next, we check the synchronize position and synchronize rotation option, just like we did for the players. We add the Photon View and Photon Transform View classic components to this object as well, and check the synchronize rotation option. We place the aimPoint object at index 0 under enemy tank. For the subject, similar to aimPoint in player blue, we set the Y value to 1. And for RayPoint, we set the Y value to 0.5. Just like we did for enemy turret, we also need to add the Photon Transform View classic components to both the tower and cannon of enemy tank. So in enemy tank, we select the tank-free tower object. Add the Photon Transform View classic component and check the synchronize rotation option. We do the same for tank-free cannon. As you may have noticed, for the subject, which is the body of enemy tank, we behaved exactly like we did with the body of tank-free blue. We added the Photon View component, and the reason for this is that we want to control the subject directly in the code using a method like tank pitch. For the subject, we also have the same components as player blue. Next, we select the subject and similar to enemy turret, we add an empty object named detector. The subject will later be added to the players as well. Just like what we have here, we need to add the sphere collider and Photon View components to this detector as well. We no longer need this player, so we remove it from the scene. For enemy turrets, the pivot of the tower is placed here, and the pivot of the cannon is here. When the turret aims at a player, the aiming works correctly on the tower, while the aiming happens at this point on the cannon. It would be better if the pivot of the cannon was slightly higher. We will work on this issue later. Fortunately for the tank, the pivot of the tower is in the correct place, and the pivot for the cannon is also in an appropriate position, so we don't need to adjust the pivots. For now, we don't need to work with this object, so we temporarily disable it. Next, we select the detector and create a new script named enemy locking system. Then add it to the object. We also create locking system script in the assets folder and open it in Visual Studio. In this class, we want to define the abstract method update detection list, so we must define this method in the abstract class as well. Any class that wants to inherit from this script will have to override this method. We go to enemy locking system and inherit from locking system instead of mono behavior. We press the Alt and Enter keys and then implement the abstract method of the locking system class. We define the detection tag field, and similarly, we define the turret and turret tilt fields. At the follow, we define two variables of type quaternion named default toward aim and default toward tilt aim to store the initial rotation of the turret and turret tilt. The next field is aim speed, where the speed of aim is specified, and also the detection radius, which is used for the sphere collider. The next variable is a list of objects which are detected based on the detection tag and is named detection list. Next, we have the accessor for the sphere collider and photon view. Finally, we have the if detected object property, which becomes true whenever an object is detected. We add the awake method to the script, and in this method, we reference the photon view accessor. In the start method, we call the init coroutine method. And here we first reference the sphere collider and then assign values to this trigger and radius field. Next, we declare a list of game objects and the variables default toward aim and default toward tilt aim. In the update, the aim to object method is called, and by pressing Alt and Enter, we create this method. Under this method, we add unity's untrigger enter and untrigger exit methods. In the untrigger enter method, objects detected within the specified radius of the sphere collider based on the detection tag are added to the detection list. In the untrigger exit method, objects that exceed the radius are removed from the detection list. In the aim to object method, if no objects exist in the detection list, the rotation of the turret and turret tilt are immediately reset, and the reset turret and turret tilt method is called. And then if detected object property is set to false. Otherwise, we check the first item in the detection list. If this item is null, we call the update detection list method and immediately use return to skip the execution of the following lines. If it's not null, we store this object in the target transform variable. Then call the rotate turret and rotate turret tilt methods. And set the if detected object property to true. We use Alt and Enter to create these three methods. There is no need for these exception lines, so we remove all of them. To reset the rotation in the turret and turret tilt, we use the rotate turret method and assign it to the local rotation of both objects. In the rotate turret method, we first assign the desired rotation variable to the rotation obtained from the lock rotation method, which comes from the direction between the target transform and turret transform. Next, we use the Euler method to constrain this rotation to only rotate around the y-axis. Finally, we use rotate toward to rotate the turret toward the desired rotation obtained. We copy all these lines and paste them into the rotate toward tilt method. Then we replace the corresponding arguments accordingly. The important point here is that in this method, in the second line, we restricted the desired rotation to rotation around the y-axis. However, in this case, we need to consider rotation around both the y and x-axis, because the turret tilt object is located under the turret, and any rotation on the parent affects the child as well. So instead of 0, we should replace it with desired rotation that Euler angles.x. So here we used Euler angles.x and Euler angles.y for the turret tilt object. We save the script and return to Unity. To better understand the code for the rotate turret tilt method, here we rotate the turret by about 30 degrees around the y-axis and rotate the turret tilt by about 20 degrees around the x-axis. Now, if we remove the turret tilt, which is labeled as turret underscore heavy machine 01 underscore top from being a child, you will see that the rotation previously applied to the y-axis in the parent will also be applied to this object. And this is exactly what we explained here. We reset the turret tilt and turret objects, then return to the script. In this method, update detection list, we call the update detection list coroutine method. In this coroutine, we first rebuild the detection list and disable the sphere collider. After 2 seconds, we enable the sphere collider again. We save the script and return to Unity. Next, we select the enemy tank object, click on the tag, and then click on Add Tags. By pressing the plus button, we add the tags player and enemy and assign them to the corresponding objects. So we assign the enemy tag to the enemy tank object. Also, don't forget to add this tag to the object that has the collider component as well. For the enemy turret object which has a box collider, assign the enemy tag in the same way. We go to the resources folder and assign the player tag to all the players. For the final test, we add the cube to the scene attach the rigid body component to it, and assign the player tag. In addition, we add the aim point object as a child to the cube. We replace the title cube with test object. For the freeze rotation, we check the X, Y, and Z axis. And for the freeze position, we check the Y axis. We select the detector object in enemy turret and assign the defined fields. For the detection tag, we select the player tag. For the turret, we assign this object. And for turret tilt, we assign this object as well. Then we run the game. Now if we move the subject, you'll see how the torus follows the test object. Note that when the test object moves out of the detection radius, the rotation of the turret and turret tilt is reset again. In this case, the rotation on the y-axis of the turret is 57.7 and the rotation on the x-axis of the turret tilt is minus 21.6. If we move turret tilt out of the turret's child hierarchy, you'll see that the subject also inherits the parent's y rotation. This is the practical example of the concept we covered in the script. Now we return to the enemy locking system script. At the follow, we want to change this script from single player to multiplayer. So we go to untrigger enter and add this if statement at the beginning of this method. Adding this if statement at the start ensures that the player executing this script is always the master client. So in places where needed, it's essential to add this line. We change these methods to public, then copy and paste them. We also modify the name of each method and the arguments for each one. These methods are going to be synchronized over the network. And in Photon, we use RPC calls to achieve this. So we place the PUN RPC attribute above each of these methods. Instead of using the transform data type in each method, we use vector tree. To call these RPC methods, we proceed as shown here. In the second parameter for target players, we use RPC target.allBuffered to ensure that this method reaches all players who join the room and gameplay later on. If we had used RPC target.all instead of RPC target.allBuffered, the message would have been sent only to players who had already joined the room and the game. We can use the name of method in the first parameter instead of hard-coding the RPC method name as a string like this. This way, we avoid hard-coding the method names. We copy this line and paste it into the next two methods and changing only the RPC method name. In these methods, in addition to the first two parameters, we need to send other variables as parameters, according to the order defined in each RPC method. We save the script and return to Unity. Place the enemy turret object in the appropriate position Then we return to the sample scene and run the game. You'll see that the aiming in the turret is working correctly. We stop the game and return to scene 1. Select the enemy tank and enable it. Let's also place the enemy turret here. Let's adjust the position and rotation of this object to better align it, ensuring it's positioned exactly on the ground. Here we have the enemy locking system script, which needs to be added to the detector in enemy tank as well. So we go to the detector in the tank and attach this script. Similar to enemy turret, we assign the fields that are present in the script. Next, we want to work on the pivot of turret tilt or turret heavy machine 01 top. And as much as possible, we aim to place this pivot near the beginning of the barrel. So by selecting turret heavy machine 01 or turret, we create an empty object and rename it to turret tilde. We then raise the object slightly to place it near the barrel. I think a value of 1.5 would be more suitable for the Y position. In this case, we place the turret underscore heavy machine 01 underscore top object under this new object so that it will have rotation around the x-axis. Next, we attach the Photon Transform View classic component, which was previously attached to this object, to the new turret tilt object and remove it from the old one. We then replace the turret tilt field in the enemy locking system script with this new object. We save the scene and return to the sample scene, then run the game once again. It seems that everything is working correctly so far, and there are no issues. We stop the game and return to scene 1. We change the detection radius value to 60 for both enemies. Then we return to the sample scene and run the game once again. We stop the game and return to scene 1. We place this enemy here and the other one here. Then we change the detection radius to 20 for both. We set the radius for both enemies in the sphere collider to 0.0001. We double-click on Player Blue in the Resources folder to open it in the prefab editor. We want to create the detector object for the players as well. So we right-click on Player Blue, create an empty object, and rename it to Detector. We click on Add Component and add the Photon View component to this object. Then, we add the Sphere Collider component as well, setting the radius to 0.0001. Now we need to add the detector object and these two components to the other players as well. Alternatively, we can right-click and copy this object, and then select player green and paste that onto it. We do the same for player red as well. Next, we want to add a new script called player locking system to the detector. To do this, we plan to use the enemy locking system script as a reference for creating the new script. So we select the enemy locking system script in the assets folder, duplicate it, rename it to player locking system, and then open it in Visual Studio. Here we change enemy to player. We select the detector object and attach the player locking system script to it. Then we open it in Visual Studio. Since the if statement has already been used earlier, it might not be necessary in the update detection list method. Let's review it one more time to be sure. Yes, we've already used this conditional expression in this part, so there is no need to use it again. We can remove these two lines here. We need to do the same for enemy locking system as well. So we go to this script and remove the same two lines from the update detection list method. We save the script and return to Unity. Then we open Player Blue in the prefab editor and assign the fields for the detector. We repeat the same process for the other players as well and assigning the fields for the detector. Return to the scene 1 and then open the sample scene and run the game. If you've noticed, now the player is aiming at the enemies as well, and all the code we've written is working correctly. We stop the game and check it once more in multiplayer mode. In this case, the game is working correctly and there are no issues, except for the low speed and high ping, which are related to the internet and not the game itself, especially when using a VPN.